Let's begin. Today is August 30th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 3, 5, 9, 11, 16, and 22. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on our grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A will look at our middle digit, the square digit, and compare it to the number 3. So should the value of square be less than 3? Should it be equal to 3? Or should it be greater than 3? Criteria card B looks at our first digit, the triangle digit, and will let us know whether its value is an even digit or an odd digit. Criteria card C looks at our 3-digit solution and will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2? Maybe all 3 are 3. Criteria card D looks at our first 2 digits, triangle and square, and compares them. So should the value of triangle be less than square? Should they be equal? Or should the value of triangle be greater than square? Criteria card E looks at our 3-digit solution, but this time it'll let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? And finally, criteria card F will look at our 3-digit solution from triangle to square to circle, and will let us know a little bit about the ordering of those digits. So should the digits appear in an ascending order, meaning, as an example, 1, 3, 5? Should they appear in a descending order, as in the example 4, 2, 1? Or should they have no order? So let's take a look at the example 2, 3, 1. Notice that it goes from 2 to 3, it increases, and then it goes from 3 to 1, then decreases. That shift from increasing to decreasing, and in other examples from decreasing to increasing, that's one way to define no order. We've also seen other puzzles where you have consecutive digits that are equal to each other. For example, something like, say, 2, 2, 5. That from 2 to 2, since there is no increase or decrease in value, that's another way that you can define no order in a 3-digit code. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I want to test is I want to know a little bit about that first digit. So let's go ahead and test criteria card B. Okay, so the Turing Machine does not approve of my choice. I did pick an odd 3 for triangle. Since it disagrees with it, it's letting me know that indeed triangle should be an even digit. So let's go ahead and type that up in our notes for section B. And that is that triangle is an even digit. And since it is even, I can go ahead and cross out all of the odds for triangle. So crossing out 1, 3, and 5. Next, let's go ahead and test criteria card E to find out a little bit about the ratio of even to odds. Okay, so the Turing Machine does approve of my proposal. Notice that in 314, I do have 2 odds to a single even. So it's basically letting me know that yes, it's true that there should be less even than odds. So let's go ahead and type that up in section E. And that again is that even is less than odd. And since we have already confirmed that triangle is even and I should have a majority of odds, that means that triangle and square are actually odd. So let me go ahead and add a note down here, just as a reminder that yes, square and circle are odd. And because they are odd, that means I can go ahead and cross out the evens in both square and circle. So crossing out both 2 and 4. So as you can see, we have an idea of what our solution should be. It should be something that's even, odd, odd. Okay, so let's see. We do have this criteria card that tells us how many 3s there might be. We also have a criteria card that lets us know the comparison of the first 2 digits. Trying to see what would benefit us going into the second round. So I do have at least a single 3. So we know they can't all be 3. So we could have 2, 1, or even no 3s. Let's see. And we would be comparing in D an even and an odd. So right now my triangle is larger than my square. I don't know if that really matters. Well, we know they can't, okay, so this is a way to think about it. We know they can't be equal, because we are comparing an odd and an even. And so it is a 50-50. So even if we get it wrong, we know we can deduce that it would be the third option. So yeah, let's go ahead and test criteria card D. Okay, but it did approve of my proposal. As I stated earlier, triangle is larger than square. 3 is greater than 1, so it's true that triangle should be greater than square. So let's go ahead and type that up in the notes for section D. And that is that, again, triangle is greater than square. Okay, so what can we conclude from that? Can we cross out anything? Yeah, I think we can cross out the 5 for square, because there's no way, if square were 5, what would triangle be? There's nothing larger than 5. So no, it can't be a 5. But yes, 4 is greater than 3, and of course 1. But then 2 is also greater than 1. So yeah, so we can't cross out anything else. And so I think that about does it. Okay, well, we did complete our 3 Turing tests for round 1. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. Okay, so notice that we did not test criteria card A. That would basically tell us what square is. At this point now it's a 50-50 because we only have 2 options. We also didn't test criteria card C, letting us know how many 3s there are, which is interesting since there is an option for square to be 3. And then there's the criteria card F that lets us know something about the order of the digits from triangle to square to circle. So yeah, criteria card A at this point is a 50-50. So we do have 1 and 3, and then how would the fact that there would be, say, maybe no 3s, how would that affect our solution? If there were no 3s, I don't think there could be no 3s, because if that were the case, then it would be obvious, well, you know, since we did cross out the 5, and if there were no 3s, of course triangle would be greater than square. So I don't think that's going to be the case where there are no 3s. So I think we should have at least 1 3, but not sure if it would be square or circle. And again, notice that among the 6 criteria cards, there technically is no direct direct information about circle. So somehow the combination of the 6 criteria cards will force circle to be, whatever odd value it should be, either based on the number of threes or perhaps having to do with ordering. So what else? So I think I'm sort of inclining square needs to be 3 because, again, if you choose square to be 1, then, of course, triangle is going to be greater. So you need a little ambiguity. So if we say square is 3, then, or if there is a 3, yeah, and the other thing is, not to say that if square is 3, then would that somehow invalidate criteria card C? If square is 3, then there is a 3, but I guess there's a potential for there being duplicates. 3, 3. Let's see, what else? So perhaps there's a single 3 and it's square, but then, and maybe the ordering, if there is no order. Yeah, so square, maybe, there is a single 3 and it has to be square so that you can eliminate circle for being 3, and then the no order would force you to pivot down to circle 5. So let's go ahead and test 4, 3, 5 as our second round proposal. 4, 3, 5. Yeah, let's go ahead and try that. Okay, so let's see. So among A, C, and F, which one would be a good candidate to test? Let's go ahead and test criteria card A and see if we got square correct. Okay, yeah, we did. So yeah, square is actually equal to 3. The Turing Machine confirms that. So let's go ahead and type that up. Square is equal to 3. And of course, since it equals to 3, then you can cross off the 1. And because, if you remember, triangle needs to be greater than square, that basically eliminates triangle from being 2. So we can actually cross it out. Very interesting. So yeah, so now we have 4, 3. And I think we can deduce that there should be no order. Because, again, if you have 4, 3, 1, well, actually, maybe not. Because you could have descending 4, 3, 1. 4, 3, 3 and 4, 3, 5 are technically both no order. So, but I guess if there were, I don't know if descending would necessarily make criteria card C irrelevant. If there's just one, we already know it has to be, well, square is 1. Sorry, square is 3, but is it the only 3? We could have no order with 2 of them. So let's see, if we test the ordering, if we test the ordering and it tells us no order, then it's between 4, 3, 3 and 4, 3, 5. And yeah, I guess technically you would have to test C to see if it's one or the other. So could it be descending? I'm not sure if we can deduce one or the other. So let's go ahead and just test. Let's go ahead and test C, the number of threes. Okay, yeah, so there is only one 3. So let's go ahead and type that up for section C, and we'll just say that the solution has a single 3-digit, and because we've already established square to be 3, that means circle can't be 3. And now, yeah, we're sort of having, oops, I guess what happened? Did I delete it? Perhaps. Okay, and so now it comes down to the ordering. Could it be 431? Could it be 435? So let's go ahead and test criteria card F. And yeah, so it has no order. So that means that circle cannot be 1, because that would lead to a descending solution. And so, yeah, let's go ahead and type that up in our notes, that the solution has no order. And so that leads to 435. Okay, well, let's go confirm that 435 is a solution. So 435. All right, fantastic. And now let's see, how do we do versus the Turing machine? So let's see. So we did test everything. And in the first round, we tested B, D, E, B being the only one. And then, yeah, we were able to successfully construct a good second round proposal, which ended up being the solution. So let's go ahead and type that up, B, D, E in the first round, and then the remaining criteria cards in the second round. So B was incorrect, and then we tested D, E, and then ACF were all correct. Okay, so we beat the Turing machine by 1 question. Well, what are your thoughts? How did you solve it? Did you see anything interesting in this video? Add it to the comments. Do give it a thumbs up so that more people can find this channel. And of course, do subscribe to not miss out on any future videos. Well, until next time, have a great one.